Hey folks, Doug Blake with Body Design University. Welcome to another weekly study. In today's video, I'm going to help you navigate through a couple of those equations that you have probably seen in chapter 8, the calculating the max heart rate reserve using the max heart rate calculations using the standard, the Gelish, and the Tanaka, what we call the Tanaka formulas, and then the Carvonen method to determine target heart rate. I did see one of the students, and that's why I found this interesting, was that most folks, when they get to these parts of the book, your eyes glaze over and you just kind of go, oh my God, exercise intensity, cardio exercise intensity. Do I really need to memorize the equations, whatever the case is? Okay, take a deep breath and step back for a second. Understanding exercise intensity is very important. For the most part, the modern technological situation we're in allows us to do this without even really thinking about it. For the most part, it doesn't matter in the real world, because no matter how you dice it and slice it, in order to calculate max heart rate, which is where we generally want to start with exercise intensity from those formulaic perspectives, you can't do it anyway. You can't get true max heart rate. We use predictive equations. And so ACE is basically giving you sort of an outline and understanding of how one of the ways that we can gauge how we're going to train exercise intensity wise using max heart rate as our context from where we're going to start. So I hope that makes sense. There's any number of ways that we can calculate exercise intensity during cardio, right? So 60% of max heart rate, 70% of max heart rate, we're using max heart rate. So because ACE has given you a study companion, and that's what we're working from. In fact, the student took a picture when she was doing it. She took a picture, and that's what she posted on the Facebook page. And I thought it was really, really good question. Not that you're going to get a lot of questions like this on the test. Okay. So remember, there is the real world. You very seldom used stuff like this in a real world to begin with. It was never really, by the way, none of this was ever really designed for the average exerciser. It wasn't. Okay. We have better ways to gauge exercise intensity, right? Ventilatory threshold is basically the best way, to be honest with you, to do it, to develop a zone training scenario. But with that aside, with this information, you're probably not going to see a whole lot of questions, if any, that utilize this material. Okay, so that's that academic. But on the other hand, it's in here, so you do want to know it. It's not a bad idea to get an idea of why it's used, what it's used for. And then I'm just going to show you how simple this is. The problem is that when we throw formulas at people and just put them on paper, you got to navigate through it, and not everybody thinks and, mentally works through this stuff the same way. It's easier if you kind of look at it, or I'll explain it to you in a way where you're just simply going to say, aha, now I get it. And that's what I want to do for you here on this first slide. So here's the deal. When you are talking about exercise intensity, okay, your goal ultimately in this method, now listen to what I'm saying. When you're in chapter 8, they're telling you, ACE is telling you there's any number of ways you can do this. You can do the talk test, which is related to ventilatory threshold. You can use predicted max heart rate equations, which is what this is, okay? And this is where the vast majority of the fitness industry has put most of its time and effort, is into getting these predictive equations as close as possible to reality. Everybody is different, right? So exercise intensity, for the most part in this scenario, your goal, what is your one goal? What is the one goal that you have? What do you have to get to know at what intensity to train at? You have to make a decision on what your THR is, your target heart rate. I mean, I don't know how much simpler that gets. I need to know, if you're telling me, I'm a client, and you're telling me, Doug, we're going to do cardio and we're going to get, the benefits, blah, blah. well, I'm going to ask you one question. What level do I need to train at? What level of intensity? You're going to tell me, well, I want you to train at a heart rate of 140 beats per minute, 150 beats per minute, 125 beats per minute. Well, where'd you get that from? Well, that's your target heart rate. That's what I want you to be training at. Well, where'd you get that number from? And the answer is we have a bunch of equations that help us to determine for any individual what heart rate they should be training at. Now, remember, we're not even talking about how you measure heart rate monitor, jugular, whatever the case is, pulse. Forget about all that. We're just talking about what the heart rate is that we need to get at. Okay, so that is the first step. You've got to know what your target heart rate is. Is it 50% of max heart rate? Is it 75% of max heart rate, right? So that's going to be your target. That's the goal we want to get to. We want to be training at this percent, or we want to be training at this particular actual heart rate. That's your target. So THR is the first thing that we want to know. What do you actually want to train at? Or what do you need to train at? Is it 120, 130, 150, 170 beats per minute? What is it? Okay. So using this form, talking about these particular methodologies, your THR, your target heart rate, is the main goal. Okay. How do you do that? Well, hang on a second. The first thing you got to do to get to target heart rate, let me go ahead and pull this up for you as well so I can draw. The first thing you have to do is determine what your max heart rate is. I don't know what your max heart rate is. I don't know what yours is. I don't even know what mine is because I never got it tested. I think I got it tested once when I was in college in one of my classes. I guess I was 20 years old or 21. And we did a actual lab-based max heart rate, graded max heart rate test. I don't remember what it was. So you're not going to do that. Nobody's going to really do that unless you're in a lab setting. So how are we going to know max heart rate? How do we know what a person's true max heart rate is? We don't. So we have to what? Predict it. Predictive equations are based off of actual data from actual testing. So we got predictions. What is the one prediction that you've always heard of? 220 minus your age, right? Okay, we're going to talk about that in a second. So what do I have to do to determine target heart rate? I got to know what a person's maximum heart rate that they can ever get to is going to be. Okay. Well, in order to do that, I'm going to have to know what their resting heart rate is. That was the heart rate reserve. I got to know in order to know max heart rate, I also have to know what resting heart rate is. Not that I have to, but I want to know what resting heart rate is. Why? Because ultimately, I want to be able to determine what's known as heart rate reserve. So target heart rate must have max heart rate associated. I got to know what your max is. Now, I can use a predictive equation that just uses your max heart rate and your age, right? That's the 220 minus your age. But that's not a very effective way to do it. What we want to do is we want to know what your resting heart rate is, because if I know what your resting heart rate is, guess what I can do? I can calculate what we call your heart rate reserve. Now, I know what you're saying. What does that even mean? Well, don't worry about it. That's what you need to know. You see those four things: target heart rate, max heart rate, resting heart rate reserve. Do you know what your target heart rate is? No. Do you know what your max heart rate is? No. Do you know what your resting heart rate is? Yes. Okay, I can get that. So I'll give that a check mark. Do you know what your heart rate reserve is? No, not until I do the basic equation. I hope that makes sense. So just stay with me. You can predict. It's better than nothing. You can predict the person's maximum sustained heart rate by using a very simple formula, what we call the standard formula, which was never meant to be used in normal situations. It's known as the 220 minus your age. In other words, if I'm 20 years old, my predicted, not my real, because I don't know, I have to actually do a test. My predicted max heart rate would be 200 beats per minute. Is it 200 beats per minute for you, that particular 20-year-old? Maybe. I don't know. How about that particular 20-year-old? I don't know, but we got to choose something. And so that's one quick, down, dirty, easy way. Look, it gets close. It really does. It's inaccurate, but it gets close. And you can read that in the book. So all we're trying to do right now, logistically, is determine what a person's max heart rate is. What did we say? In order to determine target heart rate, what their target rate needs to be, first thing we need to do is get their max heart rate, right? Now, this is where some of the confusion comes in. There's two other basic ways. There's more than that, but there's two basic ways or equations that have been developed over the years to get that number a little bit more accurate, because the 220 minus your age overestimates young people and underestimates older individuals. In other words, at my age, my predicted max heart rate is this number, but in reality, it's not. It's not. In fact, the predicted max heart rate that I have according to this formula, I can train at that heart rate. My wife is the same way. In fact, my wife is able to train, just to show you the differences. If we do 220 minus your age, my wife can train comfortably at that, quote, max heart rate. Technically, she should never be able to get her heart rate any higher than that. And she consistently trains 10 to 15 to 20 beats per minute higher than that. So it's not that it's not usable. It's usable if you got nothing better to do. Well, nothing better to use, but we do. We have what's known as the Gellish formula, Gellish, right? So researcher, he came up with a little bit more accurate formula. And that's what that is. That's when you see using the Gellish et al. Formula, all they're saying is that instead of 220 minus your age, you still have a person's age, but now use an equation that's a little bit more accurate. And so if I'm 30 years old, I multiply 30 times 0.67. That gives me a number. I subtract that from 206.9. I'll be honest with you. The difference is it's not that much. There is a difference depending on your age, but it closes the gap a little bit. And that's all that is. It's just a predictive equation that's a little bit more accurate than the 220 minus your age. There were a number of other researchers, and we call this equation the Tanaka Formula. He's the first of, I think there was 3 or 4 guys that did or came up with this in this paper. He came up with another equation. It's better than the 220 minus your age. All they did was now, if you're 30 years old, you multiply it by 0.7. I just remember 208 and 0.7. And that's the easiest way I remember the Tanaka formula. All that does for you, ladies and gentlemen, that only helps you on this side of the house. It just gets you a max heart rate. That's it. All of those formulas are predictive equations that are better than the 220 minus your age formula. That's all. That's all. So you put that off to the side. You see Gellish, Tanaka, all of it. And that is for one thing, just to predict max heart rate. Hope that makes sense. When you look in your little study manual, question number 8, 8A, B, C, right, D, when you look at it, all it is asking you is saying using the standardized equation for predicting max heart rate, 220 minus your age, using the Gellish et al. Formula, then using the Tanaka Monahan Seals formula. Okay, that's all it is, max heart rate. You'll notice we haven't done anything over here with heart rate reserve or resting heart rate. Now that you have your max heart rate, you can do whatever you want with that. I can use a percentage of max heart rate. I can do anything. Okay, if my max heart rate, predicted max heart rate is 180, okay, now what? Well, I guess I should be training at 50 to 60%. Okay, where did you get that from? I don't know. It's just an arbitrary percentage. It's an arbitrary number. This is why we don't have an exact level or intensity of training for the average person. We talk about, intermediate to intense or heavy train. What does that mean? Is that 80%, 70%? This is the reason, as an aside, this is the reason why we use ventilatory threshold. Okay, that is the way, that is the most accurate way, because that gives us actual physiological responses. And that's why ACE goes with it. And it is probably the best way to sort of develop a training scenario, not the only way. So now that we've got your max heart rate, we know what your resting heart rate is. Now what we do is we move forward into what's known as the Carvonin formula. So here you have, don't let the names screw you up. There's the standard, there's the Gellish, there's the Tanaka. They're all for developing max heart rate. The Carvonin method, or the Carvonin formula, is all about determining the actual heart rate for the target percent that you're at. Well, how do you do that? Well, you have to calculate what we call heart rate reserve, and it's very simple. It's simply your max heart rate that you just calculated. That's why it was asking you that. Calculate your heart rate reserve using these 3 different methods. That's all they're saying. Calculate your heart rate reserve using these 3 different methods. If you do it this way, you get this number. If you use the Gellish formula, you'll get this heart rate reserve. If you use this, you'll get this heart rate reserve. Why? Because resting heart rate is always, it's the same. This is the number that changes because of those 3 different equations. That's all it's doing. That's all that's asking you. Because the Carvonin formula, now watch, the Carvonin formula is what's going to give you this actual number. These guys aren't giving you target heart rate. They're just telling you predicted max heart rate. That's all. So don't let the names and don't let these formulas right here, don't let them confuse you. This is the formula. The Carvonin formula is a more accurate way using this system. Okay, even using the Carvonin formula has its pitfalls, obviously, because you're still relying on what? A predicted max heart rate. It's not accurate. It's close probably. But for the most part, it's not going to be accurate because, again, it's basing its end result on what? A predictive equation. Now, and the only reason we're doing this is because the Carvonin formula simply asks you to use this calculation, your heart rate reserve, which is just your predicted max minus your resting heart rate. If your predicted max heart rate is 200 beats per minute, remember, that's coming from a predictive equation. If it's 200 beats per minute, and at rest, your resting heart rate is 50 beats per minute. We already know that. I can measure that. It's no big deal. That's a real number. What is your heart rate reserve? It's 200 minus 50. It's 150 beats per minute. And then all you do, and you're right, with the one student that made note of this, it is all math. At this point, it's simply math. So the desired heart rate, the target heart rate, just substitute target heart rate with desired heart rate. That's the heart rate I want. I want to be training at this heart rate because of the intensity that I said I wanted to train at. I want to train at 60%. I want to train at 60% intensity. I want to train at 70% intensity. Well, what does that mean? Well, using the Carvonin method, it's going to give me a literal heart rate to train at. It's going to be 150 beats per minute. You want to train at 65% intensity, 134 beats per minute, whatever that number is. So all the Carvonin formula is doing is it's taking this, it's taking that, and taking this, and it's going to pop out an actual beats per minute heart rate. And there it is. So there's your heart rate reserve. Now it's just a calculation. Heart rate reserve times, and by the way, this formula is in your textbook. Okay. And in this case, your target heart rate reserve times blah, blah, blah equals this number. That's about as simple as it gets. And in the question that's in the study manual, I think it's 60% intensity, 30-year-old, right? 30-year-old, right? 35-year-old person, right? So using these different formulas, they're not very different, to be honest with you. They aren't. All you're doing is saying heart rate reserve, which you just calculated, times, now remember, this is in parentheses, heart rate reserve times whatever the intensity is, right? What intensity do you want to train at? 80, 70, 60, I don't know, whatever it is. You multiply those two numbers and it's going to give you a number obviously smaller than what the heart rate reserve is because it's a percent of 100. You get that number and just add it back into whatever this guy was, your resting heart rate. Just add that back in. If I want to train at 60% intensity and my heart rate reserve is 150, I'm going to use that as an example. Heart rate reserve was predicted max 200 minus resting 50, the young athlete. What is the heart rate reserve? 150 beats per minute. I want to train at 80%. I'll make it easy for me. The math is too hard. I want to train at 60. I want to train at 50%. Okay. Intensity. So 50% of intensity. And that's all this is saying, right? So in this case, it was 125 times 0.6. Does that make sense? 150 times 50 is what? 5 times 5 is 25, 750, something like that, right? Something like that. Whatever that number is. I add that, whatever that number, 0.5. So it's 75 plus whatever the resting heart rate was. So it's 75 plus the resting heart rate, which in this case was 50. Now, don't confuse these two numbers. This is 50%. I wanted to train at 50% intensity. I added back in, voila, there's my target heart rate. Okay. Look, pause it, rewind it, go back, look at it. Here's what I want you to keep in mind. You've basically got these four things you're dealing with: max heart rate, target heart rate, resting heart rate reserve. You know what they are, right? Target heart rate is the heart rate you want to train at. Max heart rate is a predictive equation. Resting heart rate you can take when a person's resting, and then heart rate reserve is just the max heart rate minus the resting heart rate. And all you're doing is taking that information and putting it into this basic formula. And, once you do that, again, rewind the video and watch it again. It's very simple, very straightforward. It is math, and sometimes math requires some logical steps to go through. But once you understand it, it's pretty straightforward. And, I hope that was helpful. Once again, just keep in mind, it's not like you're probably not going to see a whole lot of questions on this, but it's helpful when you go through the materials to know and understand it. It is one quick, down and dirty, easy way to determine, even if you wanted to determine a range, you can use the Carvonen formula to develop the range. I want to train at between 60% and 75%. That's what I want to train at, intensity, right? That's my intensity. I would just do the 60%, and then you would recalculate the same thing, but use 75%. Again, ultimately, to be honest with you, we generally move towards ventilatory threshold, or we simply use, like in heart rate monitors that you wear around, they just go off a percent of max. So I hope this was helpful. Remember, subscribe to our YouTube channel. Ensure that you're getting all the content whenever it comes out. Hit the notification button. If you need clarification or you have more questions, let us know. Put a comment underneath. We are more than happy to help out and answer the questions. The goal is to help you pass the ACE exam on the first try, or if you've taken it before, to help you on a second or whatever try you are on right now. It's always a pleasure to go over this material with you. Have a great weekend, and we'll see you next week. Thanks.